Master Tutoring. So today we're going to be doing the question on the screen, which requires us to calculate the surface area of the cuboid given, and the dimensions of the cuboid are given as 12 meters from here to there, 10 meters from here to there, and 4 meters from here to there. The first thing that you must do with this diagram is to put in the dimensions all around the shape, and you must keep in mind that as you're looking at this question, you can only see three sides. Let me color the sides that you can see from the front. So we have this color, this front side. I'm going to give it this color. This is just to help you see, because when you're looking at the box, or at this cuboid rather, you can only see three parts of the shape. You can't see the whole shape. It's a 3D shape, so you can't see the whole shape. Then we also have this side. The dashed lines simply means that those are the lines that are inside the cuboid, so we can't see them from standing at this position. And then we have the top one there, like that. So this is all we have. So now we are going to put in the dimensions all around this shape. So when you look at this side, because it's 12, it has to be the same length as that, because these are parallel. So take this front face as a rectangle, and you know, with the rectangle, opposite sides are parallel and they're equal. So meaning that this is going to be 12, and then same thing goes with this one. Since this one is 10, this one has to be 10 as well. So this is going to be 10 meters, and then because this is 10, it's parallel to that side. Take this as a rectangle again. So this is parallel to that, so this is going to be 10 as well, 10 meters. And then because this is parallel to that and they're equal, this side is going to be 12 meters. 12 meters. And then now we are going to do the same thing with this 4 meter. When you look at this face, the purplish face, this side is parallel to this side and they are equal. So therefore this is going to be 4 meters as well. So we put in 4 meters. And then this side is parallel to this side, is going to be 4 meters. So all the vertical lines are going to be 4 meters. 4 meters. And then same thing goes with that line. So the dashed line in there, going from the bottom to the top, is going to be 4 meters. And then this one to that is going to be 10 meters because it's parallel to this one, and then this one and that one are going to be 10 meters. So now I want us to name these shapes. I want us to name them from 1 to 6 because there's about 6 sides. So we're going to name them. Let's name them randomly. I'm going to call this one 1, 2, 3 is the top one, and then 4 is going to be the one at the back. That's going to be 4, the one that you can't see at the back. And then this is going to be 5. So 5 is going to be like at that side that you can't see, the dashed line. See that part there? Or rather, let me do it this way, just to help you see what I'm talking about. So I'm actually talking about this one. This is going to be 4. And this one at the back is going to be 5. Rather, this is going to be 4 and this is going to be 5. Alright. And then the last one is this one at the bottom. So this is going to be face number 6. So we have about 6 faces here. 1, 2, 3. We can only see 3 of them. The other 3 we can't, which is the one at the back, the one on the other side, and the one at the bottom. We can't see them from where we are when you're looking at this box. And then now the next thing that we're going to do is to open this shape apart. is to open it apart to properly look at these shapes that we have here. So when you open it apart, you're going to have something like this. And then obviously there's going to be another thing this side. And then another one this side. We have that. And this shape. So we have about 6 shapes here. So according to the numbering, this one is 1. So we have 1 here. And then this is 5 because it's this side. So this is going to be 5. And then we have a 2. This is going to be 2 because it's this side here. This is going to be 2. Just think about it this way. You remove the top, the bottom. So you're going to be left with just 5, 1, 2, and 4. So this is 5, 1, 2, and 4. So this is going to be 4. And then now the top one, which is this one here, is going to be 3. And then the bottom one, this one there, is going to be 6. Is this one here? It's going to be 6. So now if I put these colors again, just to show you what's going on here. So this is 1, this is 2, and then we also have 3 on top there, which is colored as well. So now, to calculate the surface area, we calculate the area of each of these shapes. So surface area is going to be area 1 plus area 2 plus area 6. We have 6 areas or 6 surfaces, therefore we're going to have 6 areas that we're going to have to calculate and put them all together. So let us put in the dimensions as we've already put them around the shape. So this is given to us when looking at shape. Face number 1 is 12 meters, so this is going to be 12 meters as well because they're parallel. And then since we said this is 4 meters, this is going to be 4 meters. This is another 4 meters. At the end of 2, this is 4 meters. So all these lines, this one is parallel to that one and they are equal. Remember, it's a rectangle. So therefore, this is also going to be 4 meters. This is going to be 4 meters again, as we've already indicated on this shape. And then this one is going to be 4 meters as well, because remember, this side, the shape number 5, it's a rectangle. So therefore, parallel sides are, opposite sides are parallel and equal. So this is 4 meters. Okay, and then, so looking at 2, this is 10 meters. So meaning that this is 10 meters. 10 meters, and if this is 10 meters, it means that the top part has to be 10 meters, because remember, the opposite sides are parallel and equal. Okay, and then moving on to 6, because this is 12, this has to be 12 as well, 12 meters. And then now when you look at this shape number 3, we've already indicated that, okay, this is 12 and 12. So this is going to be 12 and 12. And this is 10 meters, which is this side, 10 meters. And the opposite side is going to be 10 meters as well, as we've already indicated on the diagram, 10 meters. And then looking at shape number 6, shape number 6 is exactly the same as shape number 3, just that it's at the bottom, because they are facing each other. Therefore, the dimensions are exactly the same. So meaning that this is going to be 10 meters, 10 meters. And then looking at shape number 4, shape number 4 is exactly the same as shape number 1 because they are on opposite sides. So therefore they're identical. So this is going to be 12 and 12 on top. Now that we have all these shapes, we can actually calculate the areas. We can calculate the areas. So starting here, area of 1, area of shape number 1 is going to be, you know, this is shape number 1, it's a rectangle, and rectangle is length times breadth. So the length 12 times breadth is going to be 4. So 12 times 4, and this gives us 48 meters squared. That is area 1. Calculating area 2. Area 2 is going to be length times breadth as well, because all these shapes actually are rectangles. So we are going to apply this formula, length times breadth. So when we look at area number 2, it's going to be 4 times 10. So this is going to be 4 times 10, which ultimately becomes 40 meters squared. And then we're going for area 3. Area 3 is going to be 12 times 10, because those are the sides. 12 times 10, which ultimately becomes 120 meter squared. Area 4 is going to be, so this is area 4, it's 12 times 4. 12 times 4, which gives us 48 meters squared. And then now we calculate area 5. This is going to be, when we look at area 5 now, we have 4. Okay, it seems like we forgot to put in the other side. So let us put in the other side here. So area number 5, it's opposite to, or as I've already indicated here, it's going to be 4 on the sides, and there's going to be 10 on top. So this side is going to be 10. We put in 10 meters, and therefore now the area is going to be 4 times 10, or 10 times 4, which is 40 meter squared. And then lastly we calculate area 6. Area 6 is going to be 10 times 12. So this is 10 times 12, which is equals to 120 meter squared. So now we've calculated all these shapes, the areas of all these shapes. Now we are going to add them here. Surface area is going to be, so we add all these shapes. So 48 plus 40 plus 120 plus 48 plus 40 plus 120. And this is equals to 416 meter squared. That is the surface area of this shape. Thank you so much for watching. I hope you've learned something today. I'm Ituta Kara, and please leave a comment if you have any questions. Thank you so much. Goodbye.